Okay. I am starting. No, you cannot, baby.
Did you make sure you have enough?
Y'all ruining my recording. Should I keep this in? Tori, turn around and be quiet. Drew, I'm gonna send this video to your mom, and you'll never be let out of the house ever again. Tori, you too. Tori, I know how to get a hold of your Monica. I know her name because it's written on your arm. It's written on your arm, nice and clear for me. Okay. I'm gonna keep this in there. Should I? It'll make people actually watch my videos. Maybe I'll get more than 22 subscribers.
Yeah.
Maybe. I don't know.
Might be a YouTube star.
Oh my gosh. What if like Ellen called me and she's like, I want that crazy math teacher on my show.
That'd be fun.
Yeah,
Okay.
Class.
Okay. Rotations. It is what it sounds like. It's when you turn a shape in the simplest of terms. Okay, so rotation, spin a shape about a center of rotation. And a figure can be rotated clockwise or counterclockwise. Okay, so as you know, clockwise is like to the right. It's the way that the clock moves. In terms of rotation, we actually rotate counterclockwise more often, and a positive rotation is actually counterclockwise. So for example, if it's like a 90-degree rotation and it's positive, it goes to the left. Clockwise is for a negative rotation. So for example, if you have like negative 90-degree rotation, it would go clockwise. Okay, what else? Moving down. All points on the image must be equidistant from the center of rotation as the points on the pre-image. And I'll show you what that means. So right here, it has this little image. This is the center of rotation, and then we have a shape. I'm gonna choose this point and draw a line to that shape. We're gonna first rotate it a positive 90 degrees. So it would rotate this way 90 degrees. And then the new shape or the image would land right here. So that's positive. So it's moving counterclockwise. If you were asked to rotate this shape negative 90 degrees, it would move here. So obviously this line wouldn't really be there. I'm just showing how it's rotated, but you can use these lines. So if you have a corresponding point, let's say this point and this point are corresponding, and if you were to draw the line to the origin, it should make a 90-degree angle if it's a 90-degree rotation. So you can use that to check whether you rotated it correctly. Okay, next. Okay, please stop tapping. Okay, so I'm going to take this slow. I'm going to focus on the concept. We're actually not going to fill in this table because it's pretty tedious. I'm just going to focus on rotating this shape. So here is our pre-image. We're going to rotate it 90 degrees at a time. So if we were to rotate this 90 degrees, it would fall into this quadrant over here. Try to visualize where you think it would actually land. See if you can do it in your head. Okay, now I'm going to draw where it would actually land after a 90-degree rotation. Did anyone picture that?
Mm-hmm.
Because some people will see it right away, some people won't. I'm one of those people. I'm probably like visually impaired with this stuff. Like, I wouldn't have got it in that exact spot. But you can kind of check yourself. So let's choose a corresponding point. Let's see point D and then point D right here. If you were to draw a line to the origin and then up to point D, it should make a 90-degree angle, and then you know that it went in the right spot. Okay, now we're going to rotate this shape 180 degrees. So 180-degree rotation would put it over in this quadrant. And if you were to continue rotating it, you would get this. I know some of you probably are able to visualize this easy. You're like, no duh, it goes there. Some of you are like, what? Okay, so if you needed to check yourself, again, take that corresponding point, point D, and make like an angle from the original D through the center of rotation, and then to this point. And it should make a straight line if your rotation is 180 degrees. Hold on, Logan. I'm recording. Remember, don't interrupt. Okay.
I was saying that piece looks like a Tetris thing.
It does look like a Tetris thing. Okay. So here we go. Now we're going to do a 270-degree rotation. That would make it go over into this quadrant over here. So 270 degree. And here's where it would land. Okay, so again, if you wanted to just check yourself, use that corresponding point. And 270 degrees this way would make the inner angle here 90 degrees. Actually, if you were to rotate this negative 90 degrees, it would land in the same spot. I do have this here. I don't know if it helps you guys visualize it, but you're like rotating it here. I don't know if that helps at all. Raise your hand if you like can see it easily enough to like draw it. That's awesome. It's always boys. Boys have better spatial reasoning than girls. Not that girls can't see it, but
Yeah.
biologically. Okay, next. So turn to the next page. Okay, so 90 degrees counterclockwise, so we're going to rotate this shape 90 degrees. Counterclockwise, that would be a positive 90 degrees, or that would be the same as a negative 270 degrees. In the other direction, it would land in the same spot. So to rotate this shape, it would land right here. So if we're rotating 90 degrees, it would land right here. Okay. If you needed to check yourself, just use a corresponding point like this point and this point. Draw lines to the origin, which is your center of rotation, and you should get a 90-degree angle. And we did. So again, just like rotating this one turn would put it right here. For those of you who are having trouble visualizing this, we have a hack or shortcut. We're going to use this rule for the coordinates. So by manipulating the coordinates, you can find the coordinates of the rotated shape. The rule for a 90-degree turn is xy becomes negative yx.
Oh, I accidentally killed them all.
What's that?
I accidentally killed them all.
Okay. Next, we're going to rotate this 180 degrees. So that would be a positive 180 degree or negative 180 degrees. It's going to land in the same spot. So if we were to take this and rotate it all the way around, we would get it right here-ish. And I'm going to draw it out too. Okay. So 180-degree turn would put it over here. And it lands right here. And then, again, choose a corresponding point, like that corner. And then if you drew a line through the origin, you should get a straight line if it went through a 180-degree turn. The rule for this one, for the points, is negative x, negative y. Then we have a 270-degree rotation. That would be a positive 270-degree, or a negative 90-degree would land in the same spot. So this is going to go over to this quadrant over here. Now I'm going to draw it. Lands right there. Our corresponding point right here. If we were to draw our little angle, we get a 90-degree angle on the interior and then 270, of course, on the exterior. And then the rule for this one is y negative x. Okay, so remember counterclockwise when rotating positive degrees, and rotate clockwise when rotating negative degrees. And there's some really good practice on Khan Academy with this as well. Next. Okay, so now we're going to practice for real with shapes. Graph the figure and its image under the given rotation. Okay, so for this, we're definitely going to use the rules for the coordinates to make sure everything goes to the right place. Rotate the figure 90 degrees counterclockwise, so that's a positive 90-degree rotation. The rule for that is xy becomes negative yx. Thing is, we don't have any coordinates at this point, so we have to pull out the number, like coordinates for each one of these points. Is that? So we have K, L, and J. Point K, L, and J. The points for point K are negative 3, negative 1. Negative 1, negative 4. Negative 4, negative 5 for J. Now we're going to take these points and perform the rule so that way we can get the correct rotation. So we're going to have K prime, L prime, and J prime. And I'm going to take each one of these points and Y goes into the X, like they switch places, and then Y becomes the opposite sign. So this would be positive 1, negative 3. So all I did was I used the rule. And this says negative y. All of my y's were already negative, so I just changed them to positive. And then I'm going to plot these points.
Isn't that counterclockwise?
Hmm? Right, it is counterclockwise. There's our rotation. Okay, so we took this and we rotated it over here. And of course, you could check yourself with like a corresponding point, maybe it's point K, it should create a 90-degree angle, which it does. Also, all the points should be the same distance from the origin. So point J should be the furthest from the origin in both shapes. So that's another way to just make sure that it's in the correct spot. Okay, next one we're doing the same thing, but now we're rotating it 180 degrees. The rule for 180-degree rotation is this becomes -x, -y. So first thing we need to do is get our coordinates for L, M, and O. Then we're going to perform the rule to get our translated point, or transformed points, I guess, rotated points. Then we get -1, -3, -3, -3, -4. 0 is neither positive or negative, it just stays itself. There's our new points that we're going to graph. And this one has been rotated 180 degrees. Again, if you needed to check your work, you could use the origin and just a corresponding point. Let's say point L, we draw a line to point L, and then to L in the other shape, and we should get a straight line for 180 degrees. Okay, and the next one. This time they give us the points, they don't graph it. So first thing I'm going to do is just graph these points on the graph. Point A is at -3, 5. 1, 2, 3, 4. Okay, so that is the original, and it wants me to perform a 270-degree rotation. So just going to pull the rule from this chart here. The rule is that for 270-degree rotation, it becomes y -x. So xy becomes y -x. So now for A prime, B prime, and C prime, I'm going to change the points. So y 3. So now it's doing 270, so it's going to land in this quadrant. And there's our rotation. Okay, and again, you could check your work, choose a corresponding point and make that angle. And it does create a 90-degree angle here, which means it's 270 in the other direction. Okay, last two. If a point 52 is rotated counterclockwise, what's that? What did you get it wrong? Okay. If 52, if 52 is rotated counterclockwise, so that's a positive 90 degrees about the origin, its image will be point what? So our original is 52. The rule for a 90-degree rotation is xy becomes negative yx. So this would become negative 2, 5, which would be this answer here. Is that what you're trying to say, Drew?
Yeah.
Cool. What? C is P?
C.
Is B.
Yeah.
Is that what you got?
D.
I got B. B. Okay. So C, how does the spinner appear after 270 degrees counterclockwise rotation? For me, I got to do it one step at a time. So if I was to rotate it 90 degrees, it would be over here. Oh. And then if I was to rotate it again, 180 would be right here.
My bad.
And then another turn for 270, it would be over here.
I was going too fast.
So it's this one.
And D was trying to throw us off.
What? Okay. One more thing. One more thing I need to go over that's on the homework that isn't part of this lesson. I'm gonna kind of squeeze it in this space right here. So just kind of make a little bubble so you can write this down. The thing that wasn't on here that's on your homework is called magnitude of rotation. What this means is how far a shape needs to rotate to land on top of itself. So for example, if I have a pentagon, a regular pentagon with all sides the same measure and all angles the same, this would need to rotate one turn to land on top of itself. So if you take 360 and divide by 5, you would get how many degrees you need to turn it for it to land on top of itself. So 360 divided by 5 comes out to 72 degrees. So the magnitude of rotation for that shape would be 72. Or like if you had a square, again, all sides congruent, all angles the same, to figure out how many degrees it would have to turn to land on top of itself, it would be 360 divided by 4, which is 90 degrees. So that's the concept. You would just take the number of sides, take 360, and then divide by that, and you'll find that magnitude of rotation. Okay, so you can begin your homework now. You can use your phones because the internet's just not consistent.